It's called first order linear differential equations. And like logistic, there's a certain form that it has to be in order to solve it the way I'm going to show you. The reason that you need to know it, or the reason that it's available, is because you can't always solve and get the y's together and the x's together. You can't always separate the variables. For example, if I give you this equation, y prime plus y equals e to the x. I realize that y prime is dy dx, and we're going to solve this in just a minute. But I could subtract y, I could subtract x, but I can't ever combine that y and the x so that I can divide and get the y's with the x's. Okay, so here is some things you need to know, like logistic, how there was a differential equation and a solution. Same thing here. This is the form of the differential equation. And this is the solution. And u of x is something new, and it's called the integrating factor. So we're going to go back to that first equation that I wrote down. Y prime plus y equals e to the x. Okay? If you can separate the variable, it's way easier than doing this. But if you can't separate the variable, this is when this comes into play. Okay? The dy dx is the y prime. Okay, so I'm trying to make this look like the dy dx form. Okay? It says dy dx plus, and then it says p of x, y. So what would p of x be? So there's like a 1 here. That's p of x. Because p of x is whatever like function is with y. It could be a number, it could be x's, okay? It'll always be in terms of x. Okay? Q of x is whatever's after the equals. So what's Q of x? Good so far? Okay? Obviously we need to know something about u of x so that we can solve it. So we need to find u of x. U of x is e to the integral of p of x. And p of x is 1. So what is the integral of 1? X. So u of x is e to the x. Okay, so when I write the equation now, I'm going to use what I just found out about p and q and u. Okay, it says y is 1 over u of x. So 1 over e to the x integral q of x times u to the x. So solving the integral, in my opinion, is hardest. But what you're going to do here is you're going to combine the e to the x's. Because they have the same bases, you can add the powers. That is the same as e to the 2x. So then you find the integral, but you don't even think about this 1 over e to the x. Okay? So think about the antiderivative here. Maybe do u substitution. What would you get for the antiderivative? 1/2 e to the 2x. And then your plus c has to go in the parentheses. It does not go outside the parentheses because it's part of the antiderivative of this. Questions? Because you're doing u substitution with the 2x, so do use 2. So the 1/2 has to come from that u substitution. Then you're going to multiply it. Okay, you multiply just through like you're doing the distributive property. That times that, that times that. Okay. All right, so we have 1/2 All right, we have e to the 2x on top and e to the x on the bottom. Subtract exponents, so that's e to the x. And then here you have to put the c over the e to the x. You can't just make it c or b or some other constant because that has an x with it. It's not a number, so this times this is not a constant anymore. It's actually a function. Okay, so y prime plus negative 2 over x, y equals x. First of all, is this in the correct form? Yes, because the y prime is the dy dx. What's the p of x? That's this right here. Then there's a y equals q of x. So what's q of x? Okay. In the process, we're going to find u. And I know that u of x is equal to e to the integral of p. All right. Think about it just a second. What's the integral of negative 2 over x?
Negative 2 of x. Negative 2 ln x.
Okay. This is tricky because you do need to change this around. You know, before I told you if you left it, we're probably okay. You really do need to change this around because if you don't, it's going to make it really complicated. Whenever you have the e and the ln, we really want them to go away. But I've got to do something with that negative 2 and make it a power first. Okay. So then you get x to the negative 2. Alright, so then the equation is going to be y equals 1 over u of x integral q of x and then u of x. Okay, what's 1 over x to the negative 2?
X squared.
Think of it as 1 over x squared. This is the same as x squared. Okay? Alright, x times x to the negative 2. That is the same as x over x squared, which is
X to the negative
1 over x. So now the integral is much easier than it looked like it was going to be. So what's the integral? Natural log of x. Don't forget your plus c inside the parentheses. And then you multiply. Okay, this problem is number 12 in the book. And I want to do it because it's different. Now, what you should know is that the equation will not always be in the right form right away. You might have to do something to make it in the right form. Okay. This one, however, when you start moving it around, you find out it's not necessarily like the others. Okay. So if you were going to try to do something with this, what would you do? Add the dy. Okay. I'm going to put the dy on this side. See, you can separate the variables on this one. And because I can separate the variables, I don't have to do all that stuff right there. Okay? So now once the variables are separated, I'm just taking the antiderivative on both sides. And then the antiderivative of sine of x. Don't forget your plus c. E to the power of and then add 1. All right, number 18. So this one, there's several things going on here. First of all, it's not yet in the right form. Secondly, they gave me a point. Okay? When they give you the point, that's where you have to solve for C. We haven't solved for C up to this point. Those were just general solutions. On this one, once we get to the form, we do have to solve for C. Okay? But we're not even in the right form yet, so I've got to figure out how to rewrite it like this. Any ideas? Divide by x to the third. See, dy dx has to be by itself. And the x to the third's there. I got to get rid of that x to the third. And then I'll decide, well, then is it in the right form? I don't know. But I'm going to divide by x to the third first. And I have to divide every single thing by it. It's in the right form now because you can see there's something in front of y and there's something on the end. It's all in x's. If y's were combined on the end, it still wouldn't be right. Okay, but it's okay. So, p of x is what? 2 over x to the third. That's this part. Q of x is all of that. 1 over x to the third, e to the 1 over x squared. U of x is the integral, e to the integral of 2 over x to the third. So I would write it as 2x to the negative 3 to think about it. Okay, think about adding 1. So x to the negative 2. Divide by the negative 2. So this is going to be e to the negative x to the negative 2. Okay, so now we're going to set up the equation. So y equals 1 over u integral q of x times u of x Okay, let's talk about these two e's right here. So e to the 1 over x squared and e to the negative 1 over x squared. If you add them, that makes 0, right? Or if I move the other one to the bottom, it would go away. These right here make e to the 0, so that's just 1, which is nice because that makes the integral easier. Now we have 1 over e to the negative x to the negative 2. You could change that if you want. And then you're going to do the integral of this, which is x to the negative 3. So what's the integral of x to the negative 3? Negative 1/2 x to the negative 2 plus c I'm okay if you want to leave it at that point right there. It might help you make the rest of it because now, see, this was the problem where it gave me a point. So I have to solve for C. Okay? It may or may not be easier for you to plug those points in and solve them if you change it around, but we'll leave it because I figure most of you are going to want to leave it. So you have 1 and E. So E is Y. 1 is X. So that's 1 over e to the negative 1. Negative 1/2 times 1 to the negative 2 is just 1, plus c. So you divide by 1 over e to the negative 1, add a half, you'll get c is 3/2. So then your final equation is, I'm not gonna rewrite it just because I don't have room, but it's right here with a 3/2 plugged in right there.